What's connected to that? Yep. It's inverted?
It's supposed to be correct. It's supposed to be. Oh, yeah? Okay. Yep. Says what?
Or something? Yeah. I just put my
I should speak in the third. Everyone is ready. So everyone's read about there's something about this. One of the original developers of SMWCon and now involved in data. Okay, okay, welcome to this well, I will just ask like 12 times accordingly, shall I, or are we now in a hurry? I think we should adjust the rate. Okay, I will do that. So, good morning, everyone. So today my talk is going to be about tricky data, which you may already have heard about. Some of you already know more, maybe don't know anything at all. And especially also what it means for SMW. So the idea is here that I would like to inquire into the relationship between SMW and big data. So what does it actually mean for us as a community? And well, the relationship can be used in many ways, and throughout the talk I'll give you several visual metaphors for what the relationship might be in some people's lives or might be in the but before I really can start to talk about Wikidata, let me talk about the very beginning of everything. Which is for us at SMWCon Wikimedia. So that was in 2005 at the first international Wikimedia conference in Kenya and Frankfurt, where we were very close at the time of being based in Tokyo and thought, okay, let's do something useful, which is interesting to Wikipedia. People who like Wikipedia, we were fresh PhD students and studies in the so we thought it could be useful for the community. We wanted to justify our presence and our credentials, our goals. And the idea we came up with at the time, which is well known now, is the semantic Wikipedia later on. And these are the original slides. So this would be like our ideology of the talk was a dedicated representative and what he showed there was quite simple. So he said, well, let's just extend Wikipedia. Basically, the only thing we need to do is we want to extend the link syntax in a certain sense, so we can say what a link means. You know, you have the link target in media, you also set a label, which is not so hard. And why not have another thing where I can also say what does this link actually mean? What's the type of link? And then you could install it on there. I think they also explain what on that is important. That's not the first slide of the talk. And he says, well, basically what we want to do is this very good project, semantic web and Wikipedia in a few easy steps. Because there's a general requirement for that, that we shouldn't confuse usage of Wikipedia to as easy as possible, and should bring immediate benefit to the user and be efficient, of course. Now, the first step, as I already suggested, is to match the link types. So you have link types, we would say properties today, of course, in this idea of playing a prominent role that we somehow would like to manage. And so we suggested, okay, why not have a new namespace for that, like a category namespace, for namespace, and then these pages could contain a description of the link type property today, and a list of links typed with this type. That's also what is defined on the property page today. Also, that wasn't actually implemented until somewhat later. I think we didn't have that. Now, the second step is to extend the link syntax from the pause side, just allow these additional things to somehow be paused. And you have to pause it and somehow keep database tables current with this information. That we install typing links. So then we just tell the users go and do that for everything. On Wikipedia, you could also do it automatically in some cases, like in tables, you have enough information maybe already to know what the meaning of the links in each column is, or you could use some machine learning approaches. And then this time, we presented that really in a way which was inspired by the very recent introduction of categories in Wikipedia. That was also something where we just had other extensions. You could now put the category on the page. It would be done by the community. So there was no centralized coordination of how to do that. You would just say, okay, you have this feature now, go and use it as you want. Step 4, the users, the immediate benefit in our view, I think, at this time at least, was that you can get RDF from it. So the idea we had was really to use which was let RDF, and clicking on it would give you some RDF export of these types, which is what we have seen yesterday. Quite easy to do, quite natural to do. And finally, step 5. This someone should use this information. So this is mainly for outside developers. It's not longer something we can be concerned with. They can use these RDF exports and create rules on Wikipedia data. Wikipedia itself does not need to change rules anymore for me. And for example, there could be powerful yet efficient searches in the article as well. This is kind of an optional extension. And step 6 was why was change. Now the fact is not at all about the better was created. Lots of things no one expected will arrive and make things we expect never happen. I think this is maybe the truest slide of all of these in retrospect. So that's what Danny presented. And he has concluded today, well, that is a perfectly knowledge base, a huge resource for research and application data, and you fit that into a very consistent for creating data on the text, and it's not just academic fluff here. And his final note was, I want to leave with a commitment to. This is an important note because we actually didn't plan to implement any of this. We just went to the community, which has a lot of PHP developers and so on, and we said, okay, here's our idea. We offer it to you, you can take it and implement it. That shouldn't be a problem. We will guide you if you like. And so we asked them all to implement it if they want. And surprisingly, this happened. There was a company called DocCheck. I don't know what they are doing these days, but they just approached us and told us, they asked us, what do you think? We have PHP developers, maybe we can help them. How long do you think this would take? Maybe 2 weeks. It should be a good advice, just this time, and that's it. All the apps is very easy to write. So this is how the very first. And this one was somehow too awesome. At some point, we realized that it does that we learn ourselves and not just something like that we develop in a company. The first version 0.1 was released still in 2005, almost right after the conference. Actually, it already had these features. The one set up work we need to do. It had checkbox, which showed the things that you had entered, because that was the only thing we could do at the time with the data. So that's what we did, and it had a very simple special semantic search, which doesn't exist anymore. You you basically had 3 empty fields, and you could enter any subset of them, and you could fill the values to search for matching patterns. Well, then things became quite fast-paced. Semantic Force was released already in 2007. One of the, I think the extension I mentioned here, I think it's last point in terms of what has helped semantic video features to be adopted widely. Later in 2007, we had the first state version, which introduced a lot of changes, like the properties were introduced, which is called distinguish relations and attributes. We had this old ask syntax was abolished, and we had the new ask function, and many more things were introduced. And well, next year after that, there was also the very first point as an instance. So if you count this in, then we are at the 12th, I think. But let's say we are at the 9th, so we celebrate it and next time. Okay, and these were the logos over time, even as developers. Okay, but this is already, we know how this turned out. Now, but what happened with the magic Wikipedia? So you could say it's kind of instruction that at this point everything went so well, and then we had community activities and extensions to our extension, and things just took their own life and had their own life. And well, semantic Wikipedia somehow became more and more remote these days as a goal. And we still thought about that a lot, of course, and we talked to people, but it turned out to be much harder than the other very successful things that we did with many years. So many years were passing, we had countless meetings and discussions, presentations, we were at almost every Wikimania. I think there was something about semantic Wikipedia, and we talked to many people. The problem really was to acquire both the funding to do such a thing, realize that project, and the mandate to actually do it. It's not just you need the money, but you also need to know that when you do it, you will get into it. And that was very difficult. There was a lot of funding in research projects. We had 3 new integrated projects, which are all multi-million euro projects, with a lot of partners that also developed to some extent. And these are all the ones that got accepted, so there are other possibilities that it didn't go so successfully. For SMW. But this is all more on the funding side than on the media side and the media side. In the media development community as such, there were a bit of mixed feelings. We have this very funny thing here. I don't know if any of you have seen that yet. There's even an IRC shortcut for that. So if you are a media with the IRC, you can create with HSS, I think, is a shortcut to place a link to the thing. Because people are increasingly annoyed about people coming there and saying we want to manage something, and they just want to build a so some of the magic had a bit of a negative connotation sometimes during some times. But over all these times, very little community is done. You know about this in Wikipedia, there's very little community nobody knows where they are. You can put something on some blog page and then hope that somebody will answer, but it's really not the community. So, in a sense, we for many years didn't really know the project. This really only changed in 2011 when there was an opportunity for funding from the LM Institute for Artificial Intelligence, which is really very closely related to the Markman Foundation, but still a different entity. So, the idea was to create this joint project proposal together with Wikimedia and Wikimedia Germany for really doing it finally. So this was something where which was based on this who is the foundation here, and Danny, who has been pushing this again further on. I think that was during Wikimedia that they had this discussion, and the idea was then to have this one. And Reeves, who was at Wilton at the time, also played a big role in helping to get this along. In the end, the idea was to matching donation, 1.2 million euro, half of it from AWS Square, half of them from other funds. So what still had to find for all this money for every euro in that donation, a matching euro from other sources, and these other sources will then be called a new foundation. And today also Yandex has contributed this year, but that wasn't the initial. So these are all donors, and they just gave their money without any requirements. So it wasn't project money in a sense, but just donated for without any requirements of detailed outcome. So this is how I arrived at Wikipedia. We were able to start the project in 2012, so that's not so long ago now. April was the official kickoff meeting we had, and the plan as it had emerged until then was slightly different from our original plan. So the idea was to have data as an official database for Wikipedia, and to use it as one single integrated knowledge base for all Wikipedia applications and all these 285 or sometimes a bit more than I can do. It's been live since November of that same year, so 2012, has been enabled on all Wikipedia editions in March 2013, and it is still developed now. You can see that the initial development teams, I think, have changed there, but I don't have you to share anymore. Danny is still on here, he's now at Google, of course, and Lydia here is now leading the development in the university. Okay, so great. So finally, things were really moving forward, right? And we have continued funding for this project. So thinking about relationship to the main media over here at this time, you might think that maybe it's more like this. We have had the initial success, we have the trust we need, and then now finally the main project can go forward. And I think some people perceived it like that. And they're skeptical and were asking, what are you doing here? It's not really using semantic media with the all new development. Is it new code? Why do you use a new software? Why is it not anymore what you plan? And to understand that, it makes sense to look a bit into how what the difference is between Wikidata and specific or semantic media with the installations. First, let me maybe go on this a bit longer. Of course, like in every Wikipedia project, you want to have open community and open editing. Don't want to prescribe anything. You want to have basically all these principles for SMW, free and easy access is also one of them. But also very important in the case of Wikipedia, more important than most other wikis, is that there's no single truth. You want to have plurality in a wide sense. It's, as I said, multilingual. So many people from different countries coming together, they may not even see one language, and also they want to integrate some knowledge into one language. So somehow you have to allow for competing information in that system, and somehow have to support it. You can't expect that you just collect the truth and everybody will say, oh, yes, that's true. Also for Wikidata, that's very important that we develop sanitary data, not just facts, but information that refers to other sources of information, such as reference. They say, I'm not claiming that this is true, I'm claiming that this source says this is true. It's very, very important distinction for the next here. It doesn't want to be primary source of knowledge, it wants to be secondary or tertiary source of knowledge, where knowledge from other primary sources is aggregated. Now, looking at the more technical side of this, Wikipedia as such is much bigger with some exceptions. As such, all 141 pages that we have for text pages here and there. That's a new thing that we don't have in normal video users. There isn't like a mixture of the data and text, but rather you have a dedicated set of pages just for data. And these pages are about what we call entities. So every that data is an entity in this data. And so far, at the moment, we have 5 of these entities. And I'm more in the future, and you can already guess how that relates to the properties. And these items as we mentioned in a wiki, they all have the same thing, but they are not too long to see because the identifiers are things like Q40 or E31, which are opaque, they don't sound like anything. They are just technical identifiers for these things. And then all the editing actually happens through a completely role-based implementation. So there's no support anymore. Or at least no edit directly. Here's another example. Well, it's from the example I told some of you will have seen these things already. So we have the Dr. Adams, which by complete coincidence has the idea to and we see here when you go to the page, on the very top of the page, you have a label and other textual information to tell you what I'm talking about. Then there is a list of statements, things that are said about that entity. And at the bottom, then you finally find a list of links to Wikipedia pages, and not only Wikipedia pages, in fact, also other pages in Wikimedia project like comments and Wikipedia. And here you can see basically links to Wikipedia articles in this case. Let's look at this in a bit more detail. So the very first thing here are what we call terms. So they are basically textual pieces of information that tell you how the thing is solved. There are different kinds of terms here. One is the label, which is the main thing that you see at the top instead of the side. Then there's description, which helps to ambiguate the label. So if there are many people called by the same name, you wouldn't add this extra information in the label like you would on Wikipedia label. So started as parentheses writer, started as parentheses scientist, on the US, but you would always just use the name as people call the thing and say this is just a letter. Then in the subtext you have a short description that can say that it's about the fact. And then in addition to this, you have a list of lists which give you alternative labels for things that are mainly used for search. So when you do use auto, you can find them. Here are the label and description is required to be totally unique. It has to be a key. You can't have two things that have the same label and the same description. And importantly, also all of these terms are associated with one language. So this is just the English set of terms that I'm showing you here. And there are in fact 350 languages supported currently, more than in data support. And you can enter data in any of the languages. And if you come to this page, the user of the language will see the data in your language. So there's no primary language in any sense, which is also very different from what we are. Also, the point here is that this language is actually not the same as the Wikipedia. So, for example, you have one Wikipedia, but we have different languages for British English, Canadian English, US English. Also, different differentiation, differentiations between other languages where Wikipedia just has one instance to join them, or maybe Wikipedia doesn't have an instance, or because there's not enough community around here to make it here. Now, the side things on the other hand, they of course relate to the Wikipedia instances. They also have a language instances, but that's not the primary way of distinguishing them. It's really the site that we refer to, and there can be several English Wikimedia projects, for example, like Wiki Voyage, or Voyage, where you have travel guides in English, and Wikipedia in English, where you have English Wikipedia. And these things are really just, as you would expect, links to other media projects. The important thing here again is that these side links are keys. So we don't just add arbitrary links here to every page and say, okay, all of this is somehow related to the thing we are describing here, but we have exactly one link following at all for one article. So we can't have several links to English Wikipedia. At most, one link per project, so it's a function of again. Conversely, also one Wikipedia article can only be connected to one item. there can't be two different items that we can say Wikipedia articles. The idea is really that there's a one-to-one relationship between Wikipedia articles and the items on Wikipedia. And we don't allow broader or narrower or somehow related or any other related like that. This was very important to ensure that Wikipedia has a grounding at some place where we know or can find out what the item actually is about. Wikipedia doesn't have a text about the thing. And so to know what you're actually describing, what the data refers to, is very important to have backups. That's something that really say, this is the one thing we're talking about, and this is what the site is. So even though they are technically getting very simple, they are really essential for how we get forward.
Okay. Yes. I'm sorry, I have a question about not allowing profit rather than narrative components. So does that mean if you go through supposedly property that form, the component would make it pass really difficult?
No, properties were discussing. So this is not properties here. So these are the sightings are really distinct from properties and statements as they are probably. Properties are not used here at all. So this is really a built-in special table that you have for every data item, but it's not, there's no commitment for that. It's really a self-function. Yeah, maybe we can come back to that question after I have been involved, so it's just explore and maybe it's the process of it. So statements are actually the richest part of Wikipedia data, and this is what you really would think of when you think of an wiki. You have property, you have value, and of course you have a reference. So everything can have references attached. That's somehow what we expect. But of course, in practice, it isn't always that simple. This is the example statement I showed you here, but there are also more complicated statements. So here you have the properties plus the value is the value, but there are small context information in this case about the time when this statement was true. So the data was part of documents from this start date to this end date in life. And this is somehow relevant. It's not just also, the reference itself has a lot of data actually. If we unfold this, you can see there are many properties that are here again. And when you have visited things, we'll also we have property values. We have these extra information which we call qualifiers, which are also properties in the past. We have a list of references that could be mentioned, and each reference is again a list of property values. And this is the thing it's called a rank, which allows you to say to rank statements a bit in order to say, for example, that one of the first, not one is maybe separated, and this little position just means more. This is not why we use get because it's not of much importance yet in practice, but the idea is that it can help you filter later on. If you imagine that you have, for example, the population of the town and the population has changed over time, then there might be other different numbers of population. And if you query just population, you want to have a reasonable result. And ranking can help you to say, okay, this is the main population in any sense of that meaning, which just gives you quick access to the thing that you would use to distinguish the main value without removing everything else, which is also okay, so that's maybe an important difference between data and media. So this extra structure is all the things. So again, if you want to consider a statement of length of the value, there is a full value, so also for the value there. With the references which each is in property value, and then the strength, which can be the first module. And we usually call the main property value parenthetic qualifiers together with strength of the system, because this is really what is taken here. And the references and principles is there. In addition to this, there are two special values that are provided. So property value pairs as such were very much likely to have been values. So properties that they have and the values do not have the type. Difference to the value is you can't change the type after you create property. Because you don't need to. Which is because as opposed to SMW, there's no reason to use the same and the other way that you want to change it is fine. Well, you can just create a new property, use the same labels for it, and change it to the new type. So in SMW, a label and identifier are the same, but you have to be able to change the data type in order to use the label, otherwise the label will be lost forever. But in big data, that's no reason to do that. So you can just take the old data and migrate that rapidly rather than like in that. There are a few data types, they are all pretty standard. I think it's not so surprising. I think this was for wiki pages in SMW also that's not so surprising. To special values, you can say that there are some values which you cannot specify any further. And you can say there's no value at all. So basically, for example, you can say and otherwise it would be very hard to capture that information. Because in that SMW and data for anything like incomplete, often the does not enter, doesn't mean that there are no shifts. And this gives you a way to record this basically kind of makes it. Okay, so looking at this again, and one comes about relation, the impression you might get is that legally this is all brand new and co-worked, and maybe SMW is kind of an outdated data model that doesn't capture all the ideas that we have in the meantime. But maybe. So underlying this is the wiki-based extension, which is also very interesting, also from the perspective of people who are not interested in the idea is that wiki data, as I said, is running a media provider. And the features that we have in addition to vanilla media wiki are all provided by this wiki-based extension, which uses a few other extensions in the library. But basically, it can be used on any media wiki to use the same set of features. To do that, wiki-based introduces something which is called content models, which is also very interesting for anybody working with media wiki, because it was introduced for native wiki data, but it's also it can be very useful for authentication. The idea of content models is that pages are not necessarily in wiki text. You can specify named pages by wiki-based initiatives, where the content of the page is not interpreted as wiki text. It could be interpreted as another type of wiki text or a completely different file format, and this will affect how people will edit it. It will affect the way that they see the history, the way that they see the statistics, they compare versions. All of this has to be updated to work with the new content. In our case, the new content models are wiki-based items and property, which really do exactly these special interfaces, create these special interfaces you see when you go to the item of properties page. But internally, it still uses much of MediaWiki in the same way that we use MediaWiki for wiki text to store the data in blobs, basically. So the data still is kept in a single text blob. It's just that this blob is not edited manually, but it's not a wiki text, but it's edited by some user. And you can imagine a lot of interesting applications for that. So that you could also try to have some other kind of content model and use all the wiki infrastructure, all the history, all the conflict avoidance, all the user management with this different type of data that's not normal. So that's a very interesting thing, and I think if we had this opportunity or this facility in the past, we might already have used it. Makes it very convenient to store data on pages in any way or format that fancies fit without having to burden the user space. Now, much of this in the case of wiki-based is based on JavaScript and JSON, so you may wonder what is actually on these blocks. Well, it's JSON JavaScript object notation, which is structured serialization format for maps and arrays that can capture the data. And, this is what you get when you read the dumps of these wikis. So if you download the exported dump file from media wiki, from Wikimedia, then you will get exactly these raw JSON logs inside the data. There's also a lot of JSON in the API, but it's a different JSON. So if you access the system through the media API, then you will also get data in JSON, but with a different structure. But this is what people use mostly, because that's the documented thing, that's the undocumented. And it makes it very convenient to use the data in documentation. So you can just write a JavaScript application and immediately read JSON and can act on this data and produce output again to send to the API to change the thing. And in fact, most of the user interface is really based on JavaScript to read and write data. So it uses its own API to implement editing. And you could do the same thing to implement editing with any kind of tool that you like to store data on the UI. The only difficulty is organization of the user modeling to make sure that this works, but otherwise it's quite simple to interact with this whole platform using JavaScript and exchange data only instead of trying to manipulate the text that you want to change data and now, the obvious question at this point is, can you actually use that in practice? I mean, it has been developed as an extension, but is it really feasible to do it today? And surprisingly, I think for many, it is possible that it is already done that. A few weeks ago, there was the EVA project. It's a research project in the which announced that they have a where they use this so that is quite a key because I think the first use of this outside of the Wikipedia infrastructure, which is really very specific and it's not clear that this is so easy. I'm not sure it will be, but it is certainly so you can actually use it in the interface. Then you get the same editing interface. You will get all the same data points in the however, if you want to use it in a way, like we get that with some of those negative I don't think that's how it's easy to reuse. Although also when you don't have a boss on language or any kind of built-in browsing also doesn't make sense. Something called the time but they don't have. So the question that arises, how do you actually get to the data? Like that. That's the API level, but what do you do to use the data if you don't have the language? And one thing that I can mention here is this project that I'm currently working on to it's all Wikipedia data, where we try to implement the Java library which allows you to process content from Wikidata in a batch mode, offline mode. I mean, online you can use the API file, use JavaScript, but doesn't give you access to the whole data. You can't use JavaScript to download the whole site. So in order to get use the whole site, you usually have to go back to dump files, but dump files contain this JSON format as a document. And in order to use all this, we thought we had to have something like a Java library that already implements all this for you and gives you the real data in Java rather than you having to pass all this text modification. So we already have a full implementation here of all the data model. We can go to the dump files to extract all the data. We can automatically download the dump files of Wikidata from the location of Wikimedia. But you could also process other dump files if you're not interested in Wikipedia. And one thing that you can do is, for example, is to export all the data. What we want to do is to provide something that will store it all over the database in after you process, so that would be interesting. Okay, so you could actually build up such a toolchain, you could install it, you could collect the data, And you wouldn't be able like this, but look at other ways to get to your data. So maybe that is adequate for your application. So we still have a new kind of relationship between the systems that somehow seem to have mutually exclusive advantages and disadvantages, and we don't go together anymore. Okay. So I will come back to the technical comparison later. Before I continue, really should talk about numbers. So I haven't really told you about how big this data is at the moment. I told you it's just 2 years old and hasn't been even edited for all that time publicly. So one might wonder what to react. And the numbers are like so that's from 2008, last time I did that count. We have 50 million items. 1,005 properties, which is interesting relationship. So if a lot less properties than what might have peer level or it's a very structured way in which the community introduces new properties. They really discuss whether the property is needed, whether other properties are used to sell it, and only then introducing properties. So it's quite a well-maintained space of properties. We have 34 million cities. So, labels, areas, and descriptions are like that. The largest number here is the labels with 74 million. Areas is much fewer than because areas are much harder to get. The label you can get even from a Wikipedia page with a relationship. But areas are extra information that is usually everybody sees. And the rest is and we also have descriptions for it. And I just go as far as to say that every time you have a description, but I think the very interesting here, that means that's the number of articles in Wikipedia and in other Wikipedia projects. So that is the total number. But on every single project, you have all the facts of these total items. So if I'm interested in Wikipedia, that's one is particularly hard. So these items, if you try to have cover a lot more than you could find on any single project. And there's really data integration platform for this things that you wouldn't have Another interesting thing is that, of course, initially the labels were generated by taking the type of people. But you can see here, there are about 10 million labels more or less than we are finding in total. These findings include links to projects that are not included. So you can see that people are actually implementing this, which are not found of any also taken into account. References also privately often. There are in total 20 million uses of references in the statement. So in the 34 million statements, there are 23 million references. Some statements may have more than one reference, some statements may have more, but it's really coverage. But interestingly, if you compare these references, compare this, then you will only find that 120,000 different references that are used. So many references are used for a large number of statements. And these are all because people have different data from sources and have then use the same reference for only large or millions of statements. Here's a more visual view of how this business has been growing. This is more work and generated by only a category. But you can see very well. So labels are the highest number, that's 40 million, 50 million, growing more than regularly. Links, you can see initially the labels were almost the same. And then at some point the labels continue to grow and don't grow that quick anymore. That's also related, of course, to the coverage that we have for the Wikipedia. So here the items, you can see initially items were growing, but at some point kind of plateaued, and they are not growing very quickly. The reason is that at some point you just have all the Wikipedia articles, and the growth continues at the rate of Wikipedia growth. you can really say that from this point on, we have all the media covered. And all the information we could easily get from that. And all the knowledge that comes from other sources statements are important here, so this line is sometimes in material but you don't see any kind of incremental, okay. So what about this volume that I told you about? Well, they are relatively rare. We have only 100,000 something statements using for that. They're used very diverse ways. Many of them are used for central context information. Others are used for other contexts, like specify which asteroid taxonomy was used to specify an asteroid. Sometimes they use it to represent multi-area connections of connections or some of course. And an important thing, however, is that leaving away qualifiers in general is not safe. So if you leave away qualifiers, we can just what it says. If something claims that was population number in 1800, so it's not just optional context. I'm not going to talk about this, but I'll do one at a time. This is about soft.org and internet.org and other examples. If you're interested in this, I can talk about this. Something I want to mention briefly is how that ultimate Wikipedia goes. You have seen now what the data actually is. And today, if you go to Wikipedia, every page on Wikipedia also exists. All languages that you see for in other languages on the left-hand side, come from the data and all based on these sides. But in addition to that, it's also possible to integrate data directly into Office. And for this, we have some specific options for Wikipedia Office population, for example, to get the value of this property only when which is very different case very long. Not very effective yet, but the value of other pages is not really formally anything, but this is the basic way to access it. More advanced way exists, you can use Zero, which is a scripting language used in media, and simple queries will become very soon. So very soon it's hoped that we will have something like we soon, which will of course change the whole data again. This also is mirrored in user numbers. You see again, this is temporary bi-weekly intervals based by users. Mainly, to be noticed here, we have a lot of users and a lot of edits. These are edits. The yellow and red ones are users who do very many edits, like the yellow ones are users with more than 100,000 edits. Mostly new using some tools. The blue ones are more professional users who have a few edits. And so you can see most fluctuation here due to the yellow thing. And overall, in spite of these power users that contribute a lot, we have had more than 42,000 distinct logged-in users who have edited on that site already. So that's really huge community, and we are very anxious to update in a broad community, not just among our users who are pushing into the data center. It's one of the most active projects on Wikimedia today, so it's only the Wikipedia has an idea. More people. And it's even stronger because due to this time granularity we have, where every data item can be edited individually, we of course naturally have a large number of edits when people change something, because you can't change many balance here and change the other one. That's maybe this is a huge loss. We have over 100 million edits of our at the beginning of the year. So this is the future. So it's really and people are using it's taking off. What does that mean for us again? So what will the future look like? SMW or Wikibase? Let's again compare what the different features are. So in semantic media wiki, you have data in wiki text, in Wikibase, you have it in special entity pages which are not text pages at all. In semantic media wiki, you have property value data, whereas in Wikibase, you have property value data plus qualifiers that give you context for the property value as class references that give you sources for the contextualized property value. So it's a bit more complicated, and you can say it's like a subset. You could express this data in Wikibase, but not the other way around. Not in In semantic media wiki, properties are the primary way of expressing data. Everything is a property. We have for data as we have special properties, for other things we have special properties. We always use properties. In Wikibase, we have a number of different forms of data. Not all of them are property-based. We have substructures that I showed you, labels, alias, descriptions. We have data type properties. We have side things. All of them have special UIs. You could represent them certainly using properties, but that's not how they do it in the user interface or even in the exports and Semantic media wiki is inherently monolingual. It's based on media wiki where you have one side language and that's it. You can't have two side language. And all the IDs we have are based on types. So the label that has to have a certain language is already identified for a property or for a page. So there's a close connection between language and things that you describe. In contrast, Wikibase is multilingual. The IDs are completely independent of labels and have no meaning in any language. Semantic media wiki uses categories like clauses. Wikibase doesn't use categories at all on the data level. Categories can be used as still a wiki, but it doesn't. They don't have any impact on what the data means or what is exported from the data. In semantic media wiki, you can edit everything in the course, thanks to semantic course, which gives you a great deal of customizability, and you can integrate it with wiki text in any way you would like to do it. Usually. Whereas in Wikibase, you have form-based editing, but the form is fixed. And if you have seen it, it's not the most visually appealing form, maybe. It's a functional form, but it's not meant to look very nice in general. That's also the second type here. So in the semantic media wiki, we have a large amount of code concerned only with visualization. How should things appear? How should query results be printed? How should the form look? Whereas in Wikibase, we have a very reduced functional layout, which is really just meant to give you a way to input data and to view the data that is currently there, but not as a nice representation layout for this. Data access primarily the killer feature of semantic media wiki are like this. Wikidata doesn't have that yet. The best way to access this API and dump files, and some people have created secondary services based on these dump files, for example, where you can do things like query answering or browse something. But this is all based on eternity that have to be written for the application. RDF export has always been a part of the media wiki. We also have a native binding to RDF stores. In Wikibase, it's not quite so developed yet. We have some RDF export on the side, but mainly you have to process the dump, and we have just done that in Codex. So if you are interested in RDF for all of Wikidata, it is there now. Also on the side of community, there are important differences. I mean, certainly the community we have in Wikibase is huge because it's a Wikipedia community to some extent. But here we have our own contract, so there is no Wikibase fund yet. So in a sense, it's an idea which you also have a large and independent user community, which makes it very interesting because people come from various directions, not just from Wikipedia. And therefore, we see a lot of use cases and projects where in Wikidata so far we mainly have experience with the Wikimedia and Wikipedia side of things, and many other things still have to be done. I think there are great opportunities there, but they have to be exploited first to see how far that. So if you see all these different features and compare that side by side, the impression you might get is maybe more like that. So this is really comparing apples and oranges, completely different features, completely different data models. But of course, that's not completely true. I mean, you have data management, collaborative data management, that's the main objective in both cases, and it's a wiki in both cases. And so we shouldn't shouldn't overlook the similarities. And the question really is, what is the future of this? How will these integrate? So what can we say about the real relationship as it might be? Well, I don't know actually, but I can offer a view. So what's the future of semantic media wiki? I think, from my perspective, the future of semantic media wiki is, in a sense, not to be discussed in isolation. I think the future of semantic media wiki has to be viewed as the future of semantic wiki media. Because I think it's much more important to understand the concept behind that and the ideas of what we want to achieve with our system, rather than to look at just one particular snapshot of the code we currently have. And of course, since nobody knows what's happening, that's a possible future. My preferred future. It's like that. So Wikibase and SMW converge to a unified collaborative semantic content management. So one thing, coming together in the middle, doing data management in a flexible way that can serve many different applications. You can easily see how that can work. You can have a joint backend for data management. Definitely, data is not so unrelated. If you have something that can capture all the Wikibase data, it can also capture all the SMW data. So the underlying data model could be some extension of the Wikibase model, should be strong enough to capture SMW. SMW is a special case where we just don't have any qualifiers and any references. Yet we can support inline queries for all this data. Why just have it for SMW? Why not have inline queries for Wikibase as well? We can also have JavaScript APIs and exports over all that data. Why limit it to one side? And we could have many other ways of inputting data into the system. So there could be more interfaces, there could be more import solutions. We have some talk about this after this keynote, where we would like to maybe use completely different sources of information in addition, and still it could be the same underlying data model and the same integration platform. And I want to mention here, because that somehow goes to my work, also reasoning could be involved here. So some people have asked, how can I infer information in semantic media using some kind of ontology, for example? Currently it's difficult, there's no real support for that. In a sense, you could say reasoning gives you additional data. It infers new data that you don't store or don't manage in other ways. And again, you could view it as a different source of data that you want to use again. So all of this would somehow integrate and share a lot of common infrastructure with, and giving you all the flexibility you want to have on the outside layers, how to actually edit this and how to work with what you use. So my final view of these two systems is much more like this the size of one coin, where the coin is the underlying concept of semantic wiki. I think a powerful concept, an important concept that is needed in many applications. And the outer appearance of these is currently quite different, and we still need to have some more integration before we can really do something there. But I think in spirit, these things really want to achieve a very similar goal and should be integrated. Okay, conclusions. So, well, simple takeaway. Wikidata is fascinating, at least for me, and quite unpredictable too. We don't know what's going to happen there. There is a lot of unexplored potential. It's only 18 months or so since really data is edited there, and we have no idea what's happening there yet. It's at the point where you can really start to use it for interesting applications, research on it, but also just exploit it in some practical tools. Tools are coming along as we speak, but there are many ideas that nobody has heard of yet, because there's just too much one could imagine. In general, semantic wikis, for me at least, have a great future, whatever happens to the individual components of individual software products here. And maybe the main takeaway of all is that things take time, really, because if you look back at 2005 and how we started naively with our 2 weeks schedule for realizing that in Wikipedia, and how long it took, and how many steps and how many people it took to enable all of this, you can see that these parts are very common. And my suggestion here is really get started as soon as you can. So it will take a few years, but be naive, as naive as you can possibly be. Don't worry too much about the long-term problems you might still encounter, just go somewhere, tell people about it, start implementing, and see how it takes off. So very enjoyable thing to observe. Okay, so these are my feedbacks. Thanks for So, yeah. Yeah, you can have time for my performance. Yeah.
This question it's my personal opinion that in these states, every year is not good right now. The media itself will, for the most part, be generated automatically from the in other words, the entire text will be created on the fly based on the structured data. So, do you have any thoughts on that?
I disagree. I don't think that's possible. Because, I mean, we have context information, that's true, but knowledge, I mean, human knowledge is so complex and so multifaceted that I think structured data can only capture one part. I think it has been reflected also much in recent years. People are only in text and not the structure. But it will not replace in text. And in fact, in some disciplines, I think it would be good to make, have a very negative narrative utility of the whole discipline if they just do data. And you can see that already in some cases, even on Wikipedia today, that people focus on data, even in history is a perfect example. So people on Wikipedia, when they had history, they focused on the big battles, the kings and rulers who had been born at some time, they focus on events, like things that you can capture in data. But history is really about, society, things that the environment that has produced a certain state. It's complex. It's something that you can't understand by just looking at a table. And this is already reflected a lot because it's much harder to maintain it, and also much more fight with it. This is your position. And somebody like this, then it's not true. It's much more difficult. So I think we have to be careful not only look at just somehow to integrate what you. I think at the same time, you're right. Many things they could be done with data. We should also understand the limits of the science and the text.
Well, what you said about interpretation, there's multiple facts that are allowed for example.
Yeah.
And so there's always an interpretation because people are not, they're not machines.
Yeah. Yes, I mean, we have this correlative science, and that's also an interesting observation we have made. The people who are looking at the data, they were somewhat critical of some of the things we have done. They said, okay, we just want to know what the population is of that city. We don't want to have all the context information. We don't want to know who said it. Because otherwise, should we pick the right population for our search engine, for example? If we have hundreds of populations from different references and different contexts, then what's the one data? They want to have a single value, and they need that. Now that's the case. Rather, we think it's opposite. We have to have more complex data models sometimes to capture as much as we can. And it won't become simple. So even now that you have structured data, you remember the slides at the beginning, or then the magic will happen, basically. You have the data and some applications will come along. It's not so easy. Now you have the data, but still interpreting this data is quite challenging. It's not just immediately machine understandable just because it's in such format. So I think there's much more work needed in the middle between very simple primitive data which just gives you a fact and free text which is just complex, but very complex data. I would like to add something on languages because you mentioned it. You can have a slide on that. These labels we have are actually quite interesting because they give you a way to translate named entities and very specialized terms across many disciplines into many languages. So if you want to translate a lot of common words from English to Japanese, you will find a dictionary for that. If you want to translate the names of provinces in India from English to Japanese, it's very difficult. You don't know where to look. And we have all the data. So that's, I think, a very interesting language-based application of the data already. Ignore all the data, translating the labels. You can translate things that are not fundamentally people. And so that's something one could really have a look at. I think with the Java library, has developed recently where you can have your website labeled or web page use labels from Wikipedia data, where people just select any language and all the items in your web page. So change the quality. You have things that are on Wikipedia. Any other questions?
A practical question. One of the things that I really like about SMWC is that the data is not like, it's not another place to go. But so I think until just now, I thought that we had to basically run solid attack, which would be based running on it, but you just add those extension to an existing thing.
Yes. So I think the answer here is definitely yes, because when you can aggregate SMWC with the default system, you just don't have a common store. So, and it's more complicated. I mean, the natural thing to do next would really be to say, integrate all the data to use the same backend and to interpret the data and then you can query it in the same way. Probably the more difficult, more challenging case that it's a wiki-based data and not SMWC data. It doesn't make much sense now for SMWC to develop as a solution for this because somehow the case itself needs to develop a solution to store its data. And this is the data. Then we can probably quite easily go into it and just store our data there and we'll have a common view on this. I think this should be quite possible.
You think this is
it needs to have some kind of secondary data storage. Currently, Keybase doesn't really have, for most of its data, doesn't have any special table or anything. You can't read it, and it doesn't even, it just lost, it processes when it's needed, for example, to generate some API output or to edit something, but you don't have direct index structures, for example, over those statements. And so, basically, a place where we could store our data to be uniform with that. Once they have something which they use as a secondary database for query something, then we can start thinking about adding to that database from our own pages. And hopefully then we'll have an integrated user. Of course, that still needs somebody to do it. So,
of course, to allow you to be still with
well, as I said, the starting was that we will move foundations elsewhere, and then also the Landtech has made on it. But as far as I'm informed by now, it's run by Wiki Media. So it's just continuing to run. So the people, the developers here, the team, most of them, and people work there, and are very active on this stuff. Everything is very confident publishers that are regular reporters that we keep, and a lot of open stuff that nobody uses anymore for everybody. And then all these available in very easy. So for example, numbers. We didn't have any data type for numbers until this generated. So if you look at the data and the new numbers,
Right, the therapeutic.
Yep. And just it's all sauf que les gens disent ah, ouais, c'est vrai,
I've got 16 minutes. Yes, it's necessary. Now I said it.
I'm sure it's
Can I just sort of put I'm trying to find well, we could set it to,
this gets weak.
I'm just gonna have a time to cut that.
okay, all right, well, what will you do? Right now, it's the watch. Somebody's in the money there.
Okay, just here.
And there's no way to just see. There's yeah, but it's good.
That's what I said, yes.
It was okay. I want to understand. I think that's here. This is doors. Yeah. And then
There you go. Phone needed.
Alright, I get it.
Well, that's very useful.
Hide it. Actually, once. Just practice. Just practice.
I'll just work. Such that.
Also, let's take it right.
No,
Yeah. Is it possible to move the mic across the cable? I was wondering if it sat in there.
Yeah, I put the load
I
though.
was thinking just mic, but then you'd have to make sure everybody else. I don't know.
Yeah, we could try it. Unfortunately,
It was just get a little closer.
yeah,
Put it on the table, maybe?
yeah, it's one of the payments, so you should still have.
Was that actually the camera? I thought that was just the mic.
Oh, yeah.
Oh, how interesting.
It's not recording.
I just assumed that was the camera.
Sorry, I'm recording separately as well, and hopefully out of the two of them, with the one, so, no, time at the job or here. Yeah, but doesn't show the slides.
Maybe I can get
How was that? All right, cool. That's something, but no. Yeah, I understand. Well, the part of it is where the oh yeah, you should be able to. We went back to the I'm gonna raise it. Yeah, for the screen you're in the dark. You can't have the best of both worlds here. Where's oh, it's cameras moving as well. Oh.
It doesn't matter to be so well, as long as the voices for.
Well, you want to have others.
Yeah.
A little bit more flat out as well. Are you going to be posting this slide? Yeah, that will help. Okay, well, we'll try that. I apologize. It's not very good. But, if you can, I mean, I know you want to be like, yeah, our friend.
I can do that. I have a special message for someone in Russia.
Okay.
So, that's here. In my bed.
I just want to mention that I'm going to try to get part of the we're trying to teach questions about
So we have something called collaboration using semantic associations. My name is Bernadette Clementi. I work at the Micro Corporation. My co-worker is Jason G. And my other co-worker, Susan, in the back of the room, and she'll be giving another presentation shortly. Collaborative analytics is a term we're using to describe how groups use objects that are very interconnected, interdependent, things like projects, people, customers, expertise, having interconnected objects, and they're using semantic visualization to help them grow knowledge and decision. That's sort of what we want to talk about today. We've been working with semantic wikis since about 2006. This is a screenshot of our archive virtual machine, where you can see that there's been a lot of pieces created over the years that didn't pan out, or maybe they're in a holding pattern, we're just waiting for either funding or some other changes to come about. We've got about, as one of these screen wikis that are active there. In actuality, I think we would tend to archive just before. So we've got about 20 or so in our platform. What we've been doing since fall of 2013, when we came to Semantic WikiCon last, has been sort of looking inward. Instead of chasing dollars and looking for customers, we focused in on two research projects we were lucky to get funded for internally at Myers. One of them was focused on moving our wikis onto an extranet, and Cindy will be talking a little bit more about that. And that's where she developed some work in authentication and authorization. My research project involved sort of looking at categorization, equality across in our farm, as well as improving findability and analytics. So it's mostly focused on the visual aspect of using semantics. So that's what this presentation is about. During the course of this research, however, with both of these projects, we developed a very close relationship with our enterprise IT group. And that wasn't the case the last time we were talking in Berlin. At that point, we were even dancing around the word wiki because that was a remote word. It was like, oh, we don't like that. You're an enterprise, like SharePoint, we really didn't understand. And we even used semantic encyclopedia instead because we thought that that might be more palatable. However, changing the words doesn't change the wiki way or the way of doing this kind of work. And so what happened was we really did the social thing. We worked very closely with our enterprise IT group as they were funding us to do our research. And they saw firsthand what semantic media wiki environment can do. And as a result of that, they really changed their tune, and they actually used semantic wiki in their briefings. They actually have funded us, and additionally, for a new project, and that was upgrade a very large sort of lead that became less sort of attended to by the group that started Wikipedia, and we're going to group all of our wikis under that umbrella, upgraded for 113, so it's been neglected for quite some time. And really changed the way these wikis are mined. So we're very excited about that. Hopefully we can talk about that in the fall. We've also been asked to build a design for an idea market using semantic media wiki. And so that's sort of prompted why we're asking people about performance tuning and using semantic media wiki. And thanks to Marcus, my scientific institute, and how we can help get a winning proposal for that. And so why are we doing this today? Why are we talking today? Well, users we found are motivated to contribute content when they can see, not just something for larger picture. And that picture frequently is some sort of, or maybe even a set of visualization. And so one thing that we needed to do for a particular client was that they had a lot of project pages. You can see there's there are 83 projects that we needed to look across all at once. And if we could scroll down this page, we would be able to see that, for POC, contributors, synopsis, organization tag, etc., those are all properties. Which ones were filled in and which ones weren't? So, and since we have a set of communities where we have close proximity to talking to these people, asking them, hey, can you go ahead and fill that out? Much easier for us to go through, a visualization like this and to be able to know what's been completed and what's not. It really helps finally have users go ahead and finish up assigning these properties to values. Another need that we had from a particular customer actually was the ability to be able to see gaps in stakeholders. So how this came about, we were given a spreadsheet of people's names with whether or not they were in the medical community, the material development community, testing and evaluation or operations, and what branch of the service they were in, and what organization they worked in. We were given that information in the spreadsheet. And what we did through a lot of sort of data cleansing and everything else, we were able to create this kind of a view using a number of templates. And so each one of these boxes is its own query. But to show that the white boxes were the original data that were given to us, and the green boxes, before we started adding data, were all empty. And so what we wanted to show is here are the gaps, and here's what MITRE is doing to fill those gaps. We're finding people from these organizations, and so you can see exactly what we've done. And you can also see in the white boxes from the original data, pairings where we've also identified other potential stakeholders for this particular customer. So this was an interesting way to sort of show a lot of data in a very small space. It's hard to see, but we've also combined this with semantic glossary so that when you do hover over any of these very short names, you actually get the expansion and it's actually readable. Otherwise, it's sort of like an eye chart with a lot of acronyms. But it's very powerful. When we showed this to the customer, they're extremely excited. So we were happy about that. Another visualization that we've developed ourselves is a scatter plot. Cindy built this. We'll talk to her later on. But what it is, it's a scatter plot where you've got calculated values for, in this case, it's technical readiness levels and technical assessment levels. And then the projects are shown in the correct place, and when you hover over, you get a little fact box there. Another thing that we've done, and this is why I want to talk to the camera. Where is the camera? There it is. Yuri Kekov. Thank you so much for Chat Timeline. We've been experimenting with it. We really, really like it. It's very pretty. If you were giving a live demo, you'd be able to see how it sort of expands into tracks. But a lot of our users really like it. We've combined it with the use of a bootstrap skin, as you can see up there. It's pretty cool, nice, doesn't look like a wiki anymore. The other thing that we've been working on is a semantic Gantt chart. And so what we did was we needed a Gantt chart. We found that there was a MediaWiki extension, JS Wiki Gantt, but we didn't really want to use those tags because that's how that particular extension works. You have to write the tags in the page, very laborious, just like an HTML table. And so what we wanted to do was do something different, but we weren't yet prepared to write the semantic result format extension. And so what we did was we were able to create a semantic task. We use a form, fill that out, we've got the task information, then we query for that information, but we print to the page, so we emit the actual tag information, content, and so when this page is rendered, it shows the nice semantic Gantt. And so we're sort of moving towards doing a semantic Gantt. We may also, we noticed that the semantic project management extension sort of, we don't know what's happening there, so we may want to contact them and see whether or not it should really be named that. But suffice it to say that this is something that we needed, people like it, and we're probably going to continue to work on that unless other people are also working on something like this and we should coordinate. A very interesting body of work that we've been developing, and actually Jason is the developer for this particular visualization, is an org chart. And it's a dynamic org chart. And so, here's the form that you can fill out, and you can decide, okay, is it an Army organization? What's the long name, the short name, and the parent? And after that, when you hit save, you end up getting a box where you would see its parent, and you can also see its children. And in this case, we're looking at the page for the HQDA, Department of the Army. And so right now, it's not interactive, but the next version, we'll be able to hover over the little box and be able to see the number of people that are actually associated with that organization and really help out that stakeholder project that we showed a little bit earlier. And this has been implemented as a parsing function. Another visualization that we've developed is a hierarchical builder. In this case, it's being used as a table of contents. So we had a Word document, a very large one, with best practices that we needed to wikify. And so actually, Jason actually wrote that little piece of code that parsed that Word document and created it into separate sections that became separate pages. In this case, it wasn't archery, it was something else, but I needed to sort of come up with something that would make sense for the presentation today. But when you click on any one of these line items here, these are the sections, you get something like this. So this is a sketch of history of archery in England. And we've got some breadcrumbs that go forward, backward, and up. And if I had some time, you could hit on the edit button. And what we would see in order to move these items around is to drag and drop the pages and move them around in order in this kind of thing. So thanks to Cindy for building the actual hierarchy builder as well. And that's being implemented now using some just different JavaScript library. And so now for the pièce de résistance, and now Jason, you've got plenty of time. We've got 20 minutes. Our network graphs. We have two different kinds, generally speaking. One of them is using enterprise data, and it displays that enterprise data in a wiki page. And the other one is Wikidata, not Wikidata as what Marcus was talking about, but data that's contained in a semantic wiki, and you can use that to navigate across links, whether it's within that wiki or even across it. So now, we'll go to Jason.
Thanks, Brian. So my name is Jason. I've been working with Cindy and Bernadette on the Minor Gestalt framework, our collection of wikis, for about 7 months. So I'm still pretty new to MediaWiki and Semantic MediaWiki. Please bear with me. But very excited to tell you about a couple of extensions we've been working on, which are both network graphs. One which is called Project Graph, and one which is called Wiki. And I'll tell you about both of them in just a minute. But they are built in very similar ways. So I just want to sort of give a really quick anatomy of how to build these extensions. So they each have a smaller PHP component and then a much larger JavaScript component. Being that these are MediaWiki extensions, they are for parser functions. There has to be a parser function. So the parser function written in PHP, it retrieves and parses the parameters which are passed into the wiki text. And basically what it does is it inserts the relevant DOM elements into the MediaWiki content div. This is the div that MediaWiki provides for actual wiki page content. Typically what it does is it actually inserts empty divs, which will later then be populated with content by JavaScript. It then inserts a small JavaScript snippet into MW content, and this snippet serves to create and initialize the network graph object, also given JavaScript, passing the parameters which are parsed. And then this network graph object in JavaScript handles everything. So that's all that happens on the PHP side. On the JavaScript side, these network graph extensions, they both use D3. D3 is a JavaScript library. It stands for Data-Driven Documents, and it's just a magic library. It takes care of, you can do so many different kinds of data visualizations, and it takes care of all of it behind the scenes. Really great. One of the visualizations you can do in D3 is called a force-directed layout graph. So in a force-directed layout graph, you have nodes and you have links to nodes optionally. And the great thing about D3 is that it handles all the information about the nodes, their position and their distance, the repulsive force they have, or attractive force, for you. So we basically just input a bunch of parameters for how much we want them to repulse, what kind of distance between the nodes we want, and then it takes care of everything else in the time. D3 uses SVG for drawing, actually drawing the graph, and so we do some custom SVG drawing to make our nodes and links look the way we want to. We can put in pictures and icons, we can mess with the colors and insert text, that sort of thing. These network graphs generally use some sort of an external web service to get information about the nodes and links. So we use jQuery Ajax to make these web queries asynchronously. And when the graph is first initialized, it only shows as much data as passed in originally with the parameters. But these graphs, they are dynamic. If the user wants, they can elaborate a given node. And when they do that, another series of queries are fired off to go get more data. When that data comes back from those queries, we draw the graph. So the first extension is called Project Graph. And Project Graph is a graph that shows information about different projects going on in the company and the staff who are working on these projects and the hours they're contributing. So this is motivated by portfolio managers who need to see how projects were related to the people working on them, what people were being shared from all the projects, that sort of thing. You can see what projects the person is working on. So in the project graph, there's two kinds of nodes. We have a project node, which is represented by this little folder icon. And we have staff or person nodes, which is represented by their actual picture, name, and a little power bar underneath their name, which shows the relative dollar contribution to the project. You can see that in this example, in West Fiber and Cindy are by far the largest contributors to this part function is invoked with optionally you can pass in any number of project numbers and or data numbers along with this way or this way. And it goes ahead and it's on the graph. So there's this other project number also has that code everywhere. So for this code, for this indication of the question function, this is all the data that we're displaying. But if you want to go ahead and know, for example, what other projects Alexander Lake is working on, the user can click on this node, a little plus up here, so when they click on that plus button, or queries fire off, and they get back more information about which projects Alex is. So how we built this? Well, the primary data source is an internal graph, so we've got an internal subservice, which gives that information about staffing and tasking. So we can query this service. If we query this service by employee number, it returns back a JSON file that has all the projects that this employee's worked on, as well as the hours created. Similarly, if created a service by project member, we get back a JSON file with all of the employees who worked on this project and the hours they've put into it. The only thing the service doesn't do is give us actual people names. It only gives back employee numbers, so we use another internal enterprise API to get access to their photos, their names, and other information if we want to update this more information. And just as I mentioned before, the user can click on those and allow your files more areas to enlarge. The second extension that we've been working on is called Wiki. Wiki, I believe, stands for knowledge, visualization and knowledge integration, and it's basically a Wiki page link. So in Wiki, nodes represent actual Wiki pages, and then links represent literal links, for example, literal links between these pages. So this is motivated by a need to be able to navigate the Wiki symbolically, as well as to sort of have a bird's eye view or a visual view of what pages in your Wiki and what pages are there and how they relate to each other. So a really cool thing about Wiki is that it operates over our entire Wiki farm. So since we talk about our Wiki farm, I didn't mention it briefly, but we have an active vibrant farm with over 20 or 25 wikis. And so Wiki can actually recognize links from a page in one of our wikis that goes with a page in a different one. And another really cool thing about Wiki is we've architected it to support a hook system similar to that of MediaWiki. I'll talk about this in a second. But it turns out we built Wiki in 2 extensions. Wiki actually 2 extensions. There's a basic Wiki, which is minor agnostic. It knows nothing about the Wiki farm. It's generic. It can be installed on any Wiki to analyze the page relationships there. And then we built an add-on called Wiki, which is more aware of minor-specific information. For example, it knows about the members of our Wiki farm. It knows how to get photos and staff names from our enterprise API, inflating more logos. So how can Wiki actually get the information for pages and the links between them? The primary source of Wiki is the MediaWiki API. And in particular, there are 3 core API calls we rely on to get this information. The first one, action equals query equals external links, or X links, returns any external links from a Wiki page out to the enterprise. So if we have a Wiki page, we call it A, and has a link to google.com, that link will be captured in this query if it's run on this page. The second query, action equals query links, returns internal links from a Wiki page to other pages in the same. So if we've got page A and we have a page B, and page A links to page B, that link will be captured by the second query. And we have a third query, action equals query backlink, which does the opposite. It captures links from other pages coming into this one. So if we have a third page, page C, which links into page A, then that link will be captured by this third query. So with these queries, we can get all of the information we need for page linking to each other within one wiki. But so that's all well and good for one wiki. But how can we handle the fact that we have over 25 wikis in a farm, and they don't necessarily know about each other? So if we have a wiki X and another wiki Y, and the page for X links to the page Y, from the perspective of the wiki X API, this link would show up as an external link, right? So what this means is that Wiki has to check all external links that are returned from the first query to determine whether or not they're true external links to the internet at large, or whether they're in fact links to another wiki enterprise. Another thing to consider is that on one given graph, we may have nodes from multiple different wikis. So we have nodes from wiki X, nodes from wiki Y, nodes from wiki Z. And if a user wants to elaborate on any given node, Wiki has to know which wiki it is so that it can create appropriate API. So to keep track of this, every node keeps track of its own API URL so that it can create the appropriate. In fact, every node keeps track of what wiki it belongs to and a lot of different information, including the API. Finally, as I mentioned before, we architected Wiki to be 2 separate extensions. We did this so we could support a MediaWiki-like ecosystem. So in MediaWiki, one of the ways we write extensions is through use of a function. So when a page is requested, during the MediaWiki runtime, it will periodically make calls at certain well-defined points to any functions which are registered to run at this time. These call hooks because they hook into MediaWiki. So similarly, our base Wiki actually does 95% of the work. It goes out to U3, it sets up a graph, it manages a node, and runs these queries. But for example, the base Wiki, while it has a concept of external searchable wikis, by default, it's an empty list. So if you install base Wiki on your own wiki, you don't have to farm that's fine. It'll run fine because I think that's how I want to go check external links against the list of external wikis. Empty list is very good search. But what we have is we've defined a hub that runs near start, basically right after startup for Base50, where it provides the option for any add-ons which may exist to provide a list of searchable wikis. So we built MinerWiki as our add-on, which does an internal query to get that list and then send it to Base50. So Base50 now knows what the external searchable wikis are. If you were running Base50 on your own system and you wanted to create your own add-on, which could then provide its own list of external searchable wikis, that you can. Another place where we have is Base50. Right after a node is created, it's about to add to the graph. There is an option called hook to have a further nodes or analysis customization. So one way we take advantage of this in MinerWiki is MinerWiki will analyze the URL, and it can recognize things like this is a link to our internal phone book page, and then it provides the stat photo from the phone book page. Or it can recognize that a URL belongs to the mayor.o domain, and it provides it with the MinerWiki rather than default. I hope this makes sense. I'll stop really quickly for questions, and then I'll do a really quick demo of just how this works. Yeah.
Why are you not using
So I looked into that. I'll have to go back and answer your question later once I look at it. So I can't remember the exact reason, but it didn't quite work the way we wanted. It's short and not helpful. But I did look into the possibility it doesn't quite do. Okay, so let me give you this quick demo. Alright, so we have this video, right here. So we have, in this example, we call Wiki on, we pass in the page title start page purpose, and we can see that different pages as well as one link inward, the yellow arrows are the links outward and the blue arrows are inward. We can see that we can just drag the node around, everything moves around very organically, and I didn't have to handle any of this. Like it's so magic. Because we track all of this node relationship for second and everything. You can also pan around the graph, zoom in and out about it. Other bars, pretty cool. If you look at some of the icons we have here, you can see that we're running on a wiki called Wikia, and start page, another test page, and test page A, these are all members of Wikia, so their icons reflect the Wikia. But then we have this product development which belongs to Wikia company, that's its own wiki logo. We've got the PHP toolkit which belongs to the third wiki, that's its own logo. You can see there's a link to google.com, that's a sort of an external link to the Wi-Fi icon. And over here, we can see that this is a link to our internal home page for SimSpaces. Our editor is on it, got stat photo included there, and we've got the editor logo here. So if we want to actually visit and visit the live, and it opens up the server, you can see that that was one that I mentioned before. So, you know, really good practice speed. And let's say we want to collaborate with one of these nodes to expand the graph. We know more about toolkit. So we can toolkit, and fires out a bunch of queries, get back information to all these pages. We visit the patient toolkit. We can see that patient toolkit belongs to the mobile media. And that's why I had the mobile media. So we can just sort of keep on going and elaborate the nodes over time, build the graph more and more, just start to expand and look at the tools and all that. So the great thing about this visualization is just that we can really sort of immediately see for pages that we're interested in, the pages related to it, the pages we're interested in. Sort of a way to visualize in which you can't get by following what you're saying. So that's all I have to do for the demo. So that's the last.
So our internal and external customers are interested in these kinds of interactive, dynamic, supporting this that we can do that. So it's really better for us to be able to look at what kinds of And there is a good part, and a lot of things to be able to say, especially the fourth part that you saw earlier. We're still working on making sure that when a small part comes up, it's placed in place by place. The box that shows that you want to change the way that looks. So there's a certain amount of art and being able to present a lot of information but yet not as an overload. So you can pick out patterns and get people to interact with the data and and this is not fun. It's pretty really this where results that I was just saying, and it's the this one, depending on what these sources are.
Don't close the door. Yeah, so don't close the door because then the projector will start off. Give it a small introduction. Just take it for the top.
Okay. My apologies for the delay. My name is Will Staff. I work at the Culture and Activist Group in Canada in Ottawa, and we are we're building a digital flora of Canada using flora of North America as a site control. Everyone knows what flora is, what flora treatment is. So here's an example of a flora treatment. So treatment is a taxon description, and it describes what you know about the taxon. So you can see that there's a strong sort of editorial expectation that authors will supply information in a certain order. And we'll history and publication of all these specifying certain types of information. And so, for example, this will just be something that allows there are just rural coloration, growing coloration, all the different files that describe. So this is structured text, and in theory, and parts, and I'll start that a little bit. So the goal is to ingest the data and to provide a with character-based search for fragmentation functions as well. So character-based search for a couple of reasons. One is to use as an identification tool. You mentioned you can build device and take the knowledge to be able to query or treatments based on characteristics that you observe. Another motivation is to gather evidence for any sort of hypothesis that wells may have. For example, that flower color distribution between red and blue changes as you move from the equator to the pole. And so you can say, well, one component of the evidence with support for support for adaptations. So the idea here is that there is very often wrong information in taxonomic treatment. So an author will say, believes that this plant between 2 and 8 millimeters at a certain life stage. And then somebody might say, well, here's a specimen that's 9 millimeters. We don't want to simply edit that information into Wiki because there will be contention over what's correct. And so our desire is to capture this using, is anybody familiar, raise your hands if you're familiar with the SMWC open annotation. So this is an effort, this is a working group that's been exposed to publishing a class of working draft. And this is a standard for annotating web resources and then being able to store them on annotation servers that are distinct from the server that stores the information and create over. And some of our colleagues are pushing for more facility for making data annotations. Most annotations are of textual or media resources. And use cases for annotating specifications. So We want to support that, and we want to incorporate a lot of other diversity and knowledge. So we thought maybe might be a good idea for that. So I came to this meeting. I was in New York for last year, and that was my introduction to SMW. I haven't had much time, but it was like, if I had time together for the article, illustrative system, and we sort of decided to spend more time and effort on it. So I love having any feedback if you like. So here is well, this is a slide which sort of push is a framework that some cultivars developed for managing application and sort of push the whole framework so that the applications go out to the owners of resources that they might develop. And so we see our portal as sitting in that push network. And specifically, the idea is that you have the statement, and then people might come along and make an application to that. And it's sort of cluster, and then when the revisionary author comes along, the person can view all of the applications made and decide which that they use it better. In the meantime, we'd like to make those applications available for these character queries based on certain problems, specifications, I guess, of the user. So that they might process applications back from a certain source. So again, here's the treatment. One thing I want to point out is that at the bottom of this student type description, there's a little bit of chronology. And this happens here in the search site field after most source opening. So in complete contrast to the student description, highly structured and the misuse of balance vocabulary. This is completely unstructured with no control at the top. So minimal, unreliable, and highly systematic content. So we have a colleague in Arizona on the street who does language processing as a product called Paraparser, which takes the student input and then output them out. But it's much easier to read that, so if you structure that, if you look at it now, you can screenshot from the password and go and correct the mistakes that the product makes. So here's the data pattern, two black, two white, and then you play on it, and then you look at the parser the structure of the character between the colors in black, like the and then the character so what do you do with that? Well, this is one of several on tracking this in immediately. So I think we've got, and we will have a template for statement, for character, for structure, and then representation as mentioned the set of that. Or another problem to have as well. Really, because the statements are being made, all of these assertions are being made at the on structures of the plan. It makes sense to have a separate page for each structure. So you have the plan, you have the treatment page. It says, well, this might have these structures, and then each structure has these assertions made out of it. But we didn't want to have to sort of scatter that and all of the plan and multiple pages. Then we can use it in select data. Dylan, correct me if I'm wrong, but from the experiment we did, it seems that support for sub-objects is not robust, and sometimes still unexpected results. our disease, and especially if it was nested like years and what these did was that I didn't really understand the effort to do that. But yeah. So our next approach was to just flatten everything and sort of see that here is the plant, and instead of saying this has a structure called the rank and that's why used by the parent. Oh, so that's great because then you get a the usual sort of capacity browsing and still got that lot, I think, very well. So, and appropriate with the public one. One question I have, I guess, is that as far as I can tell, those filters of the solar connection drill down because they are select metallurgy plants. The plants have sometimes have these filters. And they were all stone. And I know that there is an ability to also filter the filters in certain that you overcast filters, these need to be sort of hardwired into the category. It's sort of ideally we would have a sort of a panel of the cost and filter because the idea to filter the one that might be applied and not applied. So we're sort of looking at, at doing that somehow. And yes, I'm looking at you. I don't know who else is involved here. Get that for and get that actually couple of it. Passing thought. Another thing to notice here is that during this talk, definitely in reading up the coordination network for in the U.S. They're looking at oncology and Washington data. And the question about why aren't we using the imagery and quality model? So this is huge in the overall world, where the way that so it sort of breaks the world where they have tripartite positions where we have a subject an object is sort of a bipartite of this world. And so you might say the quality of basic architecture appears in the entity system and furthermore, basic architecture has a subclass of linked entities subclass, which also appears in these entities. So there are very few properties, and but everything's in classes. So you then describe the classes, so entity classes represent the qualities of the material data. And I have never found this. A lot of apologies really like to operate with use this methodology, and it's certainly possible, to characterize the cases under which that methodology that supports ours mapping. But I would really require that effort. And I would think about it. All right, so this is what it looks like. What about with habitat? Well, I already showed you that there's no editorial expectation for the authors to follow with respect to habitat. It's doing quite the same thing. You know, we end up with, you can't really see this, but these are all sort of single things. So it's a coastal sprout, coastal bluff, coastal slow, never offering on to the tracks, etc. You sometimes will have something like say, first site, shows more. This is a cascade housing activity. So we asked, well, what does we want to know from those from those habitats? What is the habitat left at the bottom? It's right. It's both flat or not as many as you might think. Certainly, an order of magnitude towards magnitude less than habitats right now. So this is again a little difficult to see. But here is a verbatim habitat description, and then we're wondering where does it fall if I categorize it for the categories that we care about. And so we end up with a very, very simple habitat ontology. You have habitat moisture, habitat exposure being property of the plant. So if the treatment is as significant, we say, well, people first, the original knowledge, but we rely that it has habitat moisture, which is dry, habitat incline, which is slow. If you're not Canada, and you can tell me who painted this picture, I'll buy you a beer.
Have you tried the Google search engines?
I don't think it is. If you are Canada, you can tell me this picture. All right. Tom. You have a chance to be in the street. I'm sure they have so now you can browse the data here. So we select there's a wrinkle here though, right? Because when we're querying databases, we can distinguish between the assumptions that we make for the closed world, open world assumption. And if we're making a closed world assumption, then we can interpret failure as an indication of what we're looking for. That's very helpful when we're looking for these things over which we have full information. But because but over that information, you can't make a closed world assumption because there's not that editorial expectation. There's going to be complete information. And my sentiment, I guess, is it's sort of confusing for a user to have to switch the assumptions which is very under the middle interface. So there's a forward-looking aspect of this work as well, which is to give us a stronger editorial guidance to flora, to the treatment doctors in the future. And so I think as we speak, Matt, my boss, and the companies are substituting us are working on a modeling tool that the Knights can use for drag more complete habitat descriptions of the author based on the characters that we're interested in. And so our idea is to sort of iterate through the forward-looking authoring tool almost that this is how we want to think of the world and sort of capture the features we want based on this sort of treatments. Here's another sort of, at first actually, we didn't have moisture. This is what we have. We have habitat moisture, which is property of the treatment. At first, we kept the habitat that they are, and then ascribe moisture to them. So, for example, that would be the habitat, and then on the page, the mountain, we say it has a moisture broad. However, the semantic drill down is not, how did I say, um, part of the property. And so if we what else? If you just say that you want to bigger, yeah, flat. So, oh, now of course, other than the structure conditions, we still maintain pages for the various data dimension. You can browse it and really find, for example, what are the properties yeah, okay. All right. Some next steps are integrating with the implementation framework and using SMWCon to build extension implementation based on the framework and the data to come along with something like insertion and personnel. We lose knowledge when we do that flat. So we want to create it, like for example, having pages for the structure with assertions about the properties that relate to that structure. And it's very comforting when you're on kind of UI. Then, so info is environmental policy and technology support. You can hold this to the world and make it really useful one. However, we can put maybe value in policy that is stable to program data from the service. Now, currently, the museum also discussing this. If you want to make comments, for example, say about termination law, that's not because all that's some other thing. And that, the purpose is to store that as an application. But now, they pay our application on the investment data. They will more flexibility to publish them in that way. And then it's sort of, all the and this is what I was mentioning earlier, that if we decide really to present quality data, it's important to us to do that taking two of the app as input and then allow you to browse over more intuitive SMW storage site. Well, these are the questions that you have. As I was saying, I think really what I mean is sort of intuitive, graph model world that you have subject, person, object, with this model, so one question that came up as we were exploring, looking at RDFIO, was, well, what would we use to bring in RDF from external sources, the idea of the semantic web that distributed it. So if we wanted to create various external RDF from the SMW, or the value in bringing in specific facts, or the value in using SMW as a general purpose RDF browser. Addressing this more. Those are my questions. Yes, I mean,
hands-on training strategy, especially since build that something it would be great if some program would support that.
I think there is that there are all sorts of issues that seem to be training that, and so And so in fact, the question is I'm saying that that's I don't know if you actually really know. I thought that's something that in theory it shouldn't be on my list is to look at the code. I mean, I'm really know. It's very important for us to have either a filter on each property. For example, an amateur might not know that there are 6 or 7 properties that have to do with flower color. But the flower color is something so, it's sort of couple of one thing to sort of provide, other extension. It's easy to do that, or you have it. I mean, it's certainly a proof of concept. That's cool.
All right. Got that set. All right. I am Central's provider. I come from the little while ago, that was research doing. I'm going to talk a little bit more about an internal kind of research project that I've been working on this past year, the title of which is Sustained Community Knowledge Building. So the idea of being able to build these knowledge communities, which is different and to sustain them. And so this is the first year of a multi-year effort, where the first year was sort of infrastructural. And what we did was we built upon what we've been doing for the last 6 or 7 years with semantic wikis. But we got an opportunity to do a little bit of inspection and go back and to revisit how we did some of our infrastructure. And
to take the lessons learned, to go back in. And so now we have a robust wiki farm infrastructure that will allow us to do some experimentation starting now on this aspect of sustaining these communities. So I'm going to be talking about that infrastructure, which is what we did to help build up this platform, econ platform. So our software, we don't have measured software framework, and framework these are loosely to mean the extensions that we have built to MediaWiki and Semantic MediaWiki, as well as the patterns of use that we have, what we do with the text on the front end, all the way back to how we do our front end, back end. And you can see, we started in the early days of MediaWiki 1.13 was some of our early work. We were stuck on MediaWiki 1.16 for a while. But we were able to successfully recently upgrade our whole wiki farm infrastructure up to MediaWiki 1.1, and we are just this week in the process of taking our entire production farm and upgrading it from 1.1 to 1.2, much more Jason's negative. Of course, doing this morning, and we're going to make that rather tense for him. So, anyway, so we have this MediaWiki infrastructure for our farm. On top of that, we built a lot of semantic wikis, both internal to MITRE, as well, and I'll talk a little bit about the NPN, the MITRE Partnership Network, and that was really the end result of this research for this last year, was the this infrastructure for outside of MITRE, allowing partners of MITRE customers and sponsors, to come together in this collaborative author environment and author semantic content with us in a secure environment. And I'll talk a little bit more about that. So then on top of that, we have patterns and extensions we use, things we've done, both extensions on the back end as well as ways that we use the wiki text on the front end that we have evolved over time. And then on top of that are these, this term that we've used recently, collaborative analytics, the ability to have these collaborative offering environments. So I've mentioned a few times that we tend to have wiki farms. So we want to be able to share this MediaWiki and Semantic MediaWiki extension infrastructure. And we have multiple farms. We have within MITRE, we have now our MITRE Partnership Network. We've deployed farms on customer networks as well. Each farm then can host multiple wikis, and I'll talk a little bit more about that in a few minutes as well. And a given wiki, we tend to have really tight, cohesive wikis that are topic-based for a very particular community. So it's sort of a different approach, a different use than Wikipedia, where you have the wiki that has all the content. And whereas we tend to, when we stand up one of these new wikis, we have go through semantic modeling activity with the customer to define what their first-class objects are. What are these classes? We define, what the properties would be for each of these. We try and limit it to using that 7 minus 2 rule. That we have 7 minus 2 first-class object types, and for each one we define a form, and we define a basic template that then would, these other sub-templates. We define properties that would be defined each one. And so and that allows us to, when we deploy one of these, there is a structure in place. And this helps us to bring the community together and to prevent that problem of staring at it. Okay, it's already what we do, right? So we try, and when we have a community that wants one of these, we try to go through a modeling process with them first and give them something to start with. So we say, Okay, so here's a form for a person. Fill in the information about the person. Fill in the information about their organization and the linkage to it. And that's going to start helping build the initial content. Find that as you start getting this massive content, that then it becomes sort of more self-perpetuating that can then take off. So in order to have these topic-based exams, you need to use farm. And found wiki farm is necessary so that we really individually. I needed to create one of these wiki farms to go from the ground up. So we created this wiki farm infrastructure. And we got it down to I kind of being and that's the most equated wiki one of our wiki farms. Very well defined. It should take less than minutes. Right now, there's still 6 or 7 things that I have to write the script. Yeah. So, we need for our farms, manageable software infrastructure, tools to support consistent branding across our wiki farms. So, we have a wiki farm inside MITRE. Despite the fact that each one of these wikis have some semantic model, we'd like users to feel sort of this seamless connection between these different topic-based wikis. Also, they seem like one big wiki, just have to be on a particular page. That the sidebar will have those classes listed of that particular topic-based area. And so we're working, we've actually got a research proposal next year to help us with some of this cross-enterprise farm management. Brenda also has research project on this last year addressing the quality of the content and ways to look. And she gave something as some of the visualizations of her talk of what she was using to see, are all the properties still in or something. And she was using categories as well. And then eventually we work on tools for accountability across schools to farm. And we've got some visual, we've been looking at the research expansion that Jason wrote that is the first step in that as well. And then we've got better user pages. In this meeting, we start having wikis with a little bit of your user presence across lots of different nice to be able to see, especially across the enterprise. The other thing is pretty quickly as far as our media wiki infrastructure protein executive. Your media which is semantic media, your extensions, and then on top of that, we have the semantic model that I talked about. We've got some branding, so each individual wiki will have some logo, there'll be some branding that's consistent with that, as well as branding across the enterprise. And then patterns of use, about some patterns that we can do all over the farm. And then each one of our wikis in the wiki farm will get its own pattern, branding, its own, but living together within our wiki farm. And then we need management of this wiki farm over the time. You need to deploy a wiki, and you need to take enterprise kinds of use and deploy them across the wiki farm. Here's an example of how to use that I came up with. We have a page in our wikis called about the state of the world in the community. Okay, so this is a page in the wiki, and we'd like to be able to have reviews related to this page. We'd like to have this page listed to the list. So you can find over and over again across our enterprise because they are complicated, because we wind up having entities that we put in these topic-based wikis. Often we want to have discussion about these entities. And it's helpful for us rather than using just the top page. There's more information about what it is. So we've come up with a set of forms and templates that are very useful that we replicate into the wiki. It allows to have users review an item. And we created a rating extension that we open sourced last year that allows 5-star review, I want to review take the 5-star rating, I want to review measure. And these are for a particular user, a review of the item that's on that page. Okay, so in this case, it's a review of the movie, the save. And we use this in conjunction with the edit own extension, which allows you to have protection for the namespace. In that namespace, only users who created the page can edit it. So that allows us to, when a user creates a review, some other user can't come along later and modify the review and have it attributed to the review. And we have 4 buttons that allow you to very easily go from one page to your review of that item. So it's a pattern that we have over and over again about reviews. Something else that we haven't seen as much, but we think is also useful, are to have reviews, and this is actually really key as content quality for the pages. You could also have reviews of the content of the page, which is different dimension of a review, right? One is a review of the actual thing, the movie that saved the world, and then it's also a review of the page quality. This page is inaccurate. Okay? Again, we haven't done this much, but I can certainly see that kind of reviews be helpful across the page. And another dimension is discussion. So, and then we use the top page and we use the red extension to have discussion. And this is sort of back to supporting discussion, to support a page. You know, wasn't that scene where we had all the answers, everything was great. That's a weird thing. So the discussion about, in this case, discussion about the page. We have discussion also about the page quality. What we really do that very importantly, yes, it's really well. In addition, we use lists, and you could have a user create a list of things of that type. That's their list of their favorite movies, a list of their favorite movies. All of these are ways of interact, having to use having things that we do in the text that we replicate over and over again across our release and so it is helpful for us to, in one of our goals for the next year, to work on ways of managing these categories of best across our release. So I talked a little bit about that we're doing this for our Light Information Network outside of our firewall. It's a way to support multi-organizational sharing. And once you start sharing across the enterprise boundaries, and you have multiple wiki farms, you start worrying about what if cells are smarter. And so we need to make sure that our wiki farms usually have their own authorization list. This is our wider partnership network. Without going into too much detail, it is an area outside of the wider firewall that allows customers and partners. And there it supports, there will be SharePoint. There are SharePoint community sites out there. In addition, there's a tool called Handshake that was developed. It's used for discussion, an L-based platform. And so Handshake is a discussion platform. One of the things that we're looking at in the coming year is looking at how we might integrate Handshake and for that discussion component of our wiki funds, so that the discussion can happen in this elevated platform linked from the so our requirements were that we had to get through in the second year. So we have to sort of process the miners in order to deploy outside firewall. We need to be perfect, and we went through that. We also need to easily be able to add in wikis, which we've gotten that down to a pretty simple process. You don't have to connect to authenticate. There is an OpenID Connect server that is accessible to my partners. OpenID Connect is a new standard for it. It's the latest issue. It is not wire compatible with OpenID. It is a new authentication mechanism, and we've actually developed an OpenID Connect extension, and I will be releasing that as an open source built on a PHP library for OpenID Connect that is developed open source by somebody else. We also have multiple wiki farms, which may be recommended, well organized development process where we have a wiki farm development of extensions. Actually, I urged it in the original we have a whole wiki farm that's just for backend extension development, which is basically our most volatile environment. We have a wiki farm that for front-end wiki development, where we can basically assume that the infrastructure extensions underneath that stable are wiki tested and the content stuff is much more volatile. We then have a staging wiki farm where whenever we want to take an extension and want to get it into production, we test it with production wiki content on our staging wiki farm. And then finally we have production. We actually have several production wiki farms. But each one of those is considered the most stable, and that's where we try to make sure that there's no relatively stable. I talked a little bit about OpenID Connect, which is, as I said, the deployed extension for that's OpenID Connect for authentication. Another thing that we did was we wanted to be able to, so with this multi-wiki farm environment, we want to be able to very easily take an entire wiki farm and clone it and copy it. So let's say we have a production wiki farm and we have to have a new extension on it. We want to make sure that we were really running on exactly the same software. So we deployed our software in a directory where everything is really self-contained. And we can actually tar out that entire directory structure and take it and put it on a new VM, untar it, and we've got complete replication of the first wiki farm. Then you throw an extension on it or throw some content on it, and you really see that how it works for useful breakage. So at this level, we've got an area for our web server information, configuration. We've got some information for each wiki. There's a configuration file that does some, for reason Apache, it does some Apache configuration rewrite rules that helps us to manage the access to our wiki farm, our individual wiki infrastructure. We've got our MySQL content stored right there within that second hierarchy. And then we've got our wiki hierarchy where we've got our media wiki software, which is where the global local sites file is. And then we've also got an instance subdirectory that has a subdirectory for each wiki on our wiki farm. And those have specific branding information, logos, and the icon for that particular wiki. The image directory, higher image directory for that wiki is there within that. And then we have a pre-configuration PHP file that our global settings file to right before it includes all the extensions. It calls free.php and after the very last thing was called post.php. Now it's will change a little bit with the composer change to the composer because some of the extensions don't get loaded. But before a configuration of the extension pattern we call free. And we call post again. So this gives us a very nice okay, close. Okay. So this is a nice way to have an entire movable hierarchy. So our deployment process for going through to get our wiki farm structure on the partnership network. The first thing we had to do is get our virtual machine infrastructure set so that it can host this movable wiki farm hierarchy. Developed a repeatable process for construction of the wiki farm. We laboriously went through and repeated it over and over again to make sure that we really could go through a well-known set of steps to create that hierarchical file structure. Now, once we got that up the first time, again, as I said, we can start things moving very quickly. If we're starting that up, we wanted to make sure that we had documented and knew what steps we are to do to get there. Again, developing a repeatable process for creation of an individual wiki on the wiki farm, which we want to script. We don't have it scripted yet. We have just a small set of instructions we have to develop the OpenID Connect authentication extension, which allows you to authenticate with your OpenID Connect infrastructure. In addition, there's a hook in that, where we, as Jason did with Vicky, we try and make sure that we make our software as generic and hookable as possible. So we created an authorization extension that can be used to use meeting groups to limit the scope of folks authorized to use an individual wiki. We have a single authentication server that proves that I am indeed who I say I am, but the credentials I provide. But in addition, you want to say that for a given wiki on your wiki farm, only this subset of folks are authorized. They are authentic, but they are not authorized to use the wiki. In the process of going through our info review for our my partnership network wiki farm, we actually found 2 cross-site scripting vulnerabilities. One that was actually in the MeWiki core, and so we proposed a patch for it, and I was delighted to have it approved. And so, any of you have followed the MeWiki 1.22.6 was released 3 weeks ago. My patch. That's pretty cool. And in addition to that, I had the semantic title extension had become orphaned. It was no longer maintained. I had after the Berlin SMWCon requested to take that extension over, and coincidentally, we found that there was actually a cross-site scripting vulnerability in that as well. And since I had been added to the ownership of that extension, I was very easily and patch that as well. So, with our hopefully improve the infrastructure. And so, as of April, our partnership with farm is on the outside. One of the benefits of that for the community is we do hope, while we can have close wikis on there that are protected for the individual partners, we can also have open wikis. And so we do hope to deploy soon an examples wiki that would have examples of the use of a lot of our extensions that we have open source and open source examples of wiki. We have a wiki available out there for people to play with. So now that we have this infrastructure, the interactive workforce is acknowledged building and begin, and we have some things that we plan to do next year. That I think I talked about those exactly what so I'd be happy to explain this.
Well, there's the, you mentioned maybe those who higher self or whatever. How does that work when collecting and searching across all those
Well, yeah, we have information, so we have a directory. One of our wikis serves as a directory of the wikis within our wiki farm. And it has some additional value-added information about whether the wiki, for example, is open. Obviously, a wiki is closed. A lot of our cross-reactive studies and views are not. And if you don't have access to it, you don't have access to it. And so it will not be there. You can't really mess that boundary unless you are a horse user. So obviously, yes, there are. I guess you could look at the 2 sides of that coin. That means that authorized people are not able to sit in there, but it also means that it is into the sort of different parties. Yeah. Yeah.
So after
no, I have not. I would love to have this meeting somewhere else. Definitely see it. Are we
Not very long.
Sure. Well, our weekly farm configuration steps evolved very much over time. And it was something that was sort of, it was crafted very initially. And it based upon steps, a variety of different suggested ways one could build a wiki farm. And we took that as the starting point, and then certain things evolved over time, like the fact that we realized we want each of them to be able to do a little bit of additional configurations of that pre-PHP post application evolved over time to allow visibility. And that's something, but there's some stuff recently about Composer and the fact that Composer makes it difficult to use for you within a wiki farm to turn on and off is something that we rely on to do. But we do it enough that so we'll be very interested. That's one of the things we have as part of one of our consultations. Look at that. So yeah, you're very interested. Oh, cool.
So, yeah. I don't know.
Because we have shared media for all of these individual farms. It's a perfect farm. That really would be a Thank you.
Alright, so now is the lunchtime. So basically here, when you get out of the building, if you walk in any direction, you'll see plenty of restaurants. But if you go on the wiki for the page for the event, you go to the local information page on the bottom right, provided a dozen restaurants which are in walking distance of Concordia. So people who are basically in visiting and everything, you have the options there. It also includes all the directions. And maybe as well, you have the Wi-Fi, you can get it on your phone or your laptop and it's the direction that you have to walk. Great. So, bon appetit, and we'll see you back at 2.
I want to give you after this wall.
Did you sign it?
But, oh no, I haven't signed it.
You'll have to.
Okay. Who should I sign?
You get generic
Yeah, I'll put it on.
body.
Oh yeah? Okay. Bahar?
But then I won't get the book. I know how this works.
I see. Okay.
What's semantics?
What?
Semantics.
Okay, wait, which one? I'm confused. Okay. So should I put Bahar?
Yeah.
Okay. Bahar et al.
BHHAR.
No, I'm saying et al. Like everyone.
And all.
Yeah.
Body? Wow.
Cool.
Thank you.
Great. Thanks a lot. We only have a t-shirt for you.
What?
We only have a t-shirt for you.
Oh yeah.
Oh, you have it? I didn't get it. I didn't get that. Here's the